Hey everybody, it's Mr. Zabo coming to you with a quick video about solving systems of inequalities by graphing with absolute value inequalities. So keep in mind, anytime it says solve the system of inequalities by graphing, that includes shading. The shading part is a part of the graph. It's implied in the set of directions here. So make sure you look at these as two separate inequalities first. So we will start by splitting these up. We have y is greater than or equal to 3 times absolute value of x minus 2 minus 4. And then separately we have x plus 3y is greater than negative 3. Alright, starting with our absolute value inequality. There's two key pieces of information we need to pull to graph the absolute value part of this. We need to pull the vertex, and then we need to pull the slope of the right branch. So the vertex, remember, comes from the form in here. Whatever I'm adding or subtracting to, this is x minus h becomes my x coordinate, and plus k becomes my y coordinate for my vertex. So since it's x minus 2, the x coordinate becomes 2, and since it's minus 4, it's negative 4. I can plot that. Positive 2, negative 4, that's the vertex of my absolute value. Okay. The slope of my right branch comes from the coefficient in front of the absolute value. That's a positive 3, or 3 over 1. So from my vertex, I'm going to go up 3 and right 1, up 3, right 1, up 3 and right 1, all the way until I can't go anymore. And then I'm going to go back and look at my symbol. Because this is greater than or equal to, I'm going to graph this as a solid line. I'm not going to dash this line. But I'm only starting at the vertex and going up through this point. We have an axis of symmetry here at x equals 2. So the left branch is the exact reflection of this, it winds up being a ray, over x equals 2. In other words, I'm going to go up 3, left 1, up 3, and left 1. And that pattern would continue to get my absolute value. Okay. At this point, I'm going to look at a test point. 0, 0 is here. It's on the outside, not in between the two rays. If I plug 0, 0 into my original inequality, I get 0 is greater than or equal to, well, absolute value of x minus 2. If x is 0, that's absolute value of negative 2. So it's 3 times the absolute value of negative 2, which is positive 2, minus 4. I get 0 is greater than or equal to 2. That's not true. So my test point has proven, since that's not true, that 0, 0 is not a solution. I will not shade in that outside region, that half plane. I'm going to shade inside of, and I'm going to do this really lightly here, that represents the solution. I've now graphed my absolute value inequality. Part 2 comes from graphing my linear inequality here. Step 1 is to solve for y. So I'd subtract my x from both sides, divide everything by 3, and wind up with y is greater than negative 1/3 x minus 1. Now I'm graphing my linear inequality. I have a slope of negative 1/3. I have a y-intercept at 0, negative 1. Because of my symbol, I am going to graph this as a dashed line. Start at negative 1, and I'm going to go down 1, right 3. Down 1, right 3. That's my dashed line that I will graph. Going quick, so my accuracy is not very good. Again, I'm going to test 0, 0. 0, 0 is above that line. If I put that into my original inequality, I get 0 plus 3 times 0, which is 0. I get 0 is greater than negative 3. That is a true statement. Therefore, 0 is a solution to that inequality. So when I graph on this half plane with 0, and I hopefully see the solution set is where those two graphs overlap. And that is in between the rays of the absolute value, but still above the line. So the section down here is not included. The solution is just the highlighted area.